On the afternoon of August 3, 1944, at precisely 14:30 hours, Commander William Reynolds stood on the deck of LCI 449, a 158-foot landing craft infantry vessel anchored at Hollandia, New Guinea, confronting what appeared to be an impossible engineering challenge. Approximately 200 yards away, half buried in coral sand at the edge of the runway, sat the wreckage of a Republic P-47 Thunderbolt fighter bomber. The aircraft had crashed during landing approach 2 days earlier, killing the pilot on impact but leaving both wing sections structurally intact. LCI 449 had completed 23 amphibious assault operations since arriving in the Southwest Pacific Theater in January 1944. The vessel was designed to transport 188 combat-equipped troops directly onto hostile beaches, but by August 1944, the tactical situation in New Guinea had evolved significantly. Japanese forces had been pushed back from coastal areas, and large-scale amphibious assaults were becoming less frequent. LCI vessels were being reassigned to support roles, supply transport, coastal patrol, and fire support for smaller landing operations. The standard armament on an LCI 449 consisted of 4 20mm Ehrlichen anti-aircraft guns mounted in twin turrets, fore and aft. These weapons were effective against aircraft and small boats, but inadequate for the vessel's new fire support mission. Marine commanders were requesting heavier firepower to suppress Japanese coastal positions during small unit landings. The 20mm guns lacked the range and hitting power to effectively engage fortified positions at distances beyond 800 yards. The P-47 Thunderbolt represented the heaviest single-seat fighter aircraft in American service during 1944, weighing over 17,000 pounds fully loaded and powered by a Pratt & Whitney R2800 double wasp engine producing 2,535 horsepower. The aircraft was designed as a high-altitude bomber escort and ground attack platform. For Commander Reynolds' purposes, the aircraft's speed and altitude capabilities were irrelevant. What mattered was the armament: 8 Browning M2 50 caliber machine guns, 4 mounted in each wing. Each M2 machine gun was capable of firing 800 rounds per minute. The aircraft-mounted versions featured longer barrels than standard ground-based M2 Browning machine guns, generating a muzzle velocity of 2,840 feet per second. More significantly, the guns were mounted in a rigid wing structure designed to handle the recoil forces of sustained automatic fire during high-speed flight maneuvers. The crashed Thunderbolt's right wing had separated from the fuselage on impact and lay partially embedded in coral approximately 30 yards from the main wreckage. The wing section measured 20 feet in length and contained 4 fully functional M2 machine guns with complete feed mechanisms, ammunition channels, and recoil systems. Lieutenant Junior Grade Thomas McCaffrey, LCI 449's engineering officer, examined the wing and calculated the assembly weighed approximately 580 pounds, including the structural components necessary to maintain gun alignment. LCI vessels were experiencing an increasingly difficult tactical situation in the New Guinea campaign. Japanese forces, when forced to retreat from coastal areas, established defensive positions in caves, bunkers, and reinforced structures positioned on high ground overlooking potential landing beaches. These positions were typically armed with machine guns and light artillery. When LCI vessels approached to discharge troops, they came under direct fire from these positions at ranges of 600 to 1,200 yards. The 20mm Ehrlichen guns mounted on LCI vessels had an effective range of approximately 1,000 yards against surface targets, but their light projectiles lacked sufficient penetrating power against fortified positions. The guns could suppress unprotected infantry, but could not effectively engage troops behind concrete, coral rock, or thick timber fortifications. This limitation was creating unacceptable casualties during landing operations. LCI Flotilla 4 had lost 2 vessels in the previous 6 weeks to Japanese coastal fire. LCI-337 was destroyed on June 18th when a Japanese 75mm gun scored direct hits on the troop compartment, killing 43 embarked Marines and 12 crew members. LCI-412 suffered catastrophic damage on July 9th from concentrated machine gun fire that penetrated the thin hull plating, resulting in 17 casualties. The flotilla's casualty rate was approaching levels that threatened operational effectiveness. Flotilla commanders at Hollandia were actively seeking solutions. Some vessels had attempted to mount additional 20mm guns, but this simply provided more of the same inadequate firepower. Others had requested 40mm Bofors guns or 3-inch deck guns, but these weapons were in critically short supply throughout the Pacific theater, with priority allocation going to destroyers, destroyer escorts, and larger amphibious vessels. The Navy's procurement system could not provide heavier weapons within any reasonable time frame. The salvaged P-47 wing section presented an unusual opportunity. 8 .50 caliber machine guns with proven reliability and hitting power, mounted in a single structural assembly capable of delivering concentrated fire. If this wing section could be mounted on an LCI vessel, it would provide firepower substantially exceeding the vessel's existing armament and offer the range and penetration necessary to suppress fortified positions. Commander Reynolds examined the wing section throughout the afternoon of August 3rd. The structure consisted of aluminum ribs, spars, and stringers covered with riveted aluminum skin panels. Despite the crash damage, the wing maintained remarkable structural integrity. The 4 guns were positioned in a line spanning approximately 8 feet of wing length, angled slightly to create a convergence pattern at 400 yards, standard configuration for fighter aircraft engaging aerial targets. At 1600 hours, Reynolds convened a meeting with his engineering officer, the flotilla's senior engineering specialist, and 2 construction battalion engineers stationed at Hollandia. The proposal was straightforward but unprecedented. Remove the entire P-47 wing section from the crash site, transport it to LCI-449, and mount it on the vessel's forward deck in place of the existing 20mm gun turret. The engineering challenges were substantial and unlike anything previously attempted with LCI vessels. The wing section's 580-pound weight was manageable, comparable to a 20mm twin turret assembly. However, the recoil forces of 8 .50 caliber machine guns firing simultaneously would generate approximately 5,600 pounds of recoil force, 75% greater than the existing turret. However, this force would be distributed across the 20-foot length of the wing section rather than concentrated in a single turret mounting point. The stress distribution would be different, but not necessarily greater at any single point. The engineering team proposed a solution. Fabricate a steel pedestal mount similar in design to standard naval gun mounts, but extended laterally to support the wing section's length. The mount would incorporate steel crossbeams welded to 6 deck beam locations, distributing the wing's weight and recoil forces across a larger area of the deck structure. Additional reinforcement would be welded beneath the deck, transferring forces directly to the hull's main structural frames. Ammunition supply presented a significant challenge. The P-47D carried 3,400 rounds total for its 8 guns, approximately 425 rounds per gun, stored in ammunition boxes within the wing structure. These internal boxes were inaccessible for reloading during combat. LCI-449 would need to supply ammunition from deck-mounted boxes through feed systems capable of sustaining fire during extended engagements. Chief Gunner's Mate Robert Sullivan proposed fabricating external ammunition feed systems running from deck-mounted boxes to each gun. This would require 8 individual feed chutes, each approximately 10 feet long, constructed from flexible steel conduit and routed from storage boxes positioned behind the wing mount to the gun receivers. The system was similar to ammunition feeds used on bomber aircraft, where guns were positioned far from centralized ammunition storage. Standard naval ammunition boxes for .50 caliber guns held 105 rounds in belt-link configuration. Sullivan calculated that 8 guns firing at 800 rounds per minute would consume 105 rounds in approximately 8 seconds of continuous fire. Combat experience with LCI fire support operations suggested typical engagement durations of 2 to 5 minutes with intermittent firing. The vessel would need substantial ammunition storage, at least 400 rounds per gun, totaling 3,200 rounds, to sustain a single engagement. Commander Reynolds faced a critical decision. The modification would require removing LCI 449 from operational status for at least a week. The vessel would lose its forward 20mm turret during installation. If the wing mount installation failed structurally or proved operationally unreliable, the vessel would be left with reduced defensive capability. However, if the system worked as intended, LCI 449 would possess fire support capability unprecedented for vessels of its class. On August 3rd at 1730 hours, Reynolds authorized the modification. By 0600 hours on August 4th, construction battalion engineers had begun extracting the wing section from the crash site using a mobile crane. The forward 20mm turret on LCI 449 was removed, creating workspace on the forward deck. A construction crew began fabricating the steel pedestal mount that would support the wing assembly. The P-47 wing section was transported to the dock on a flatbed truck and transferred to LCI 449 using the dock crane. The wing was positioned on the deck and carefully inspected. All 4 guns were disassembled, cleaned, and tested for function. Remarkably, 3 guns were in perfect working condition. The 4th gun required replacement of the barrel, which was obtained from another crashed P-47 at the Hollandia airfield. The pedestal mount design evolved during fabrication. Initial designs called for a simple rectangular frame, but structural analysis revealed this would create stress concentration points where the mount contacted the deck. The final design incorporated a trapezoidal frame with 6 mounting points distributed across 3 deck beam locations. The mount stood 24 inches high, positioning the wing section at an elevation that cleared the deck railing while maintaining a depression angle suitable for engaging shore targets. Lieutenant McCaffrey used surveying equipment borrowed from the construction battalion to verify alignment. The process required 6 hours of incremental adjustments, with the wing section being lifted and repositioned multiple times. The final alignment positioned the guns with a 2-degree depression angle and slight inward cant to create optimal convergence at the target distance. The ammunition feed system construction proceeded simultaneously with the wing installation. Chief Sullivan and his team fabricated 8 feed chutes from flexible steel conduit typically used for electrical cable routing on naval vessels. Each chute was 10 feet long and 2.5 inches in diameter, sized to accommodate .50 caliber ammunition belts without binding. The chutes were routed from deck-mounted ammunition boxes positioned 8 feet behind the wing mount, running forward and upward to connect with the gun receivers. Ammunition storage was a significant concern. Standard naval ammunition boxes held 105 rounds, insufficient for sustained fire support operations. Sullivan fabricated custom ammunition boxes from steel plate, each holding 400 rounds in continuous belt configuration. 8 boxes were positioned behind the wing mount, secured to deck fittings to prevent movement during firing. The total ammunition load of 3,200 rounds weighed approximately 650 pounds. The gun charging system presented an unexpected complication. P-47 guns used pneumatic pressure from the aircraft's engine-driven compressor system to charge the weapons before flight. LCI 449 had no comparable pneumatic system. Sullivan modified the guns to accept manual charging, installing hand-operated charging handles adapted from spare parts. This modification added approximately 3 minutes to the pre-combat preparation sequence, but eliminated the need for installing a separate compressor system. LCI-449 was returned to operational status on August 9 at 1400 hours. Initial stability testing revealed the wing mount's weight and forward position affected the vessel's trim noticeably. The bow sat approximately 4 inches lower in the water than normal. Chief Engineer Thomas Brennan compensated by redistributing ballast water and relocating spare parts from forward storage to aft compartments, restoring acceptable trim. Firing trials were scheduled on August 11th in a designated weapons testing area 15 miles offshore from Hollandia. A target was constructed from wooden pilings driven into the seabed in shallow water, with plywood sheets mounted to simulate building walls. The target was positioned 600 yards from LCI-449's firing position, typical range for fire support operations. Gunner's Mate 2nd Class James Tolliver was assigned as primary gunner for the wing mount. Tolliver had extensive experience with .50 caliber weapons, having served as an aerial gunner on B-17 bombers before transferring to the Navy. He positioned himself behind the wing section at a simple control station consisting of a ring sight mounted on the pedestal and a trigger bar mechanism that fired all 8 guns simultaneously. The first test firing occurred at 10:15 hours on August 11th. Tolliver manually charged all 8 guns, a process requiring approximately 2 minutes. He aimed at the target's center mass and fired a 5-second burst. The result exceeded all expectations. All 8 guns fired simultaneously with perfect synchronization. The sound was described by observers as similar to continuous thunder rather than distinct gunfire. The target sustained devastating damage. Approximately 530 rounds struck the target area in a concentrated pattern roughly 8 feet in diameter. The plywood sheets were completely shredded. Several wooden pilings were severed at the waterline. The demonstration of concentrated firepower was extraordinary and far exceeded the destructive capability of the vessel's previous 20mm armament. However, the recoil forces presented serious problems. The forward deck flexed visibly during firing, and several deck plates showed signs of stress deformation near the pedestal mount. More concerning, the vessel's bow nipped noticeably during sustained fire, affecting stability. The mount itself remained secure, but the deck structure was clearly experiencing forces beyond its design specifications.
Lieutenant McCaffrey immediately ordered installation of substantial deck reinforcement. Over the next 3 days, construction battalion welders installed steel reinforcement plates beneath the forward deck. These plates measured 12 feet by 20 feet and were 3/8 inch thick, welded directly to the hull's main frames. The modification added approximately 800 pounds to the forward section, requiring further ballast adjustment, but it eliminated the deck flexing problem entirely. Additional firing trials on August 15th demonstrated the reinforced installation's reliability. Tolliver fired 20 separate bursts totaling approximately 1,200 rounds. The guns operated flawlessly. The ammunition feed system experienced 3 malfunctions, all caused by ammunition belt damage rather than feed chute design problems. Once damaged belt sections were replaced, no further malfunctions occurred. The convergence pattern proved highly effective for shore bombardment. At 600 yards, the 8 gun streams converged into a pattern approximately 6 feet in diameter. At 800 yards, the pattern expanded to approximately 12 feet. At 1,000 yards, the pattern measured roughly 20 feet in diameter, but remained devastating against area targets like buildings or trench lines. The system provided effective fire support at ranges from 400 to 1,000 yards. Commander Reynolds scheduled LCI-449's first combat operation with the wing mount for August 18th. The mission involved supporting a marine company landing at Cape Sansapor on the western tip of New Guinea. Intelligence indicated Japanese forces had established defensive positions in caves and bunkers overlooking the beach. The Marines required fire support to suppress these positions during the assault.
LCI-449 departed Hollandia at 0400 hours on August 18th, accompanied by LCI-455 and LCI-462 as troop carriers. The formation arrived off Cape Sansepor at 0615 hours. Japanese positions were identified on ridge lines approximately 600 to 800 yards inland from the beach. Standard procedure called for the LCI vessels to approach within 500 yards of the beach and provide covering fire while troops landed. At 0630 hours, LCI-449 took positions 700 yards offshore, and Tulliver commenced firing at identified Japanese positions. The wing mount delivered approximately 800 rounds in sustained bursts over 3 minutes. The effect on the Japanese positions was immediate and decisive. The concentrated fire destroyed several visible bunker positions, collapsed cave entrances, and suppressed all observable defensive fire. Japanese forces attempted to return fire with machine guns and light mortars, but the volume and accuracy of fire from LCI-449's wing mount made sustained defensive action impossible. The Marines landed with minimal opposition. Post-assault reports indicated that Japanese defenders had abandoned their positions or been killed by the preliminary bombardment. The landing was completed with 0 Marine casualties from defensive fire, highly unusual for opposed amphibious operations. LCI-449 returned to Hollandia at 1800 hours on August 18th. Post-combat inspection revealed the wing mount had performed flawlessly. Approximately 1,400 rounds had been fired during the engagement. No mechanical failures occurred. The deck reinforcement showed no signs of stress damage. The ammunition feed system operated reliably throughout the combat sequence. News of LCI-449's successful fire support operations spread rapidly through LCI flotillas in the Southwest Pacific. Within 72 hours, the flotilla commander at Hollandia requested detailed technical information about the wing mount installation. Reynolds prepared a comprehensive report including structural drawings, ammunition feed system diagrams, and combat effectiveness assessment.